In this second video, we're going to be looking at how to solve a logarithmic equation algebraically. The general steps might seem kind of similar to the last video, and that's because they are. Step 1, similarly to last video, we're going to be isolating our logarithmic part of the equation. The only difference this time is we also might have to condense multiple logs down into a single log. Step 2 is to exponentiate both sides. That might sound kind of fancy, but I think you will see when we get to the examples that it's not actually too complicated. Once step 2 has canceled the log for us, step 3 is just to solve for x like we would in any normal equation, and then step 4 is to check our answer. Now, what I mean by check our answer with this kind of problem is, if you recall from back in, I believe, Chapter 4, Section 3, if we have a function that is log of x, the domain of that is just x has to be greater than 0. It can't be negative. So what that means when we're checking our answers is we have to make sure we cannot do the log of a negative number. So let's jump into our first example. Step 1, condense and isolate our logs. Well, in this case, all we have to do is condense. So we're going to combine these two logs into one log using our product property of logs. So we become log base 6 of x minus 5 times x. Right? Addition between two logs becomes multiplication inside of the log. We're still equal to 2. We can simplify that a little bit. Log base 6 of distribute the x, we get x squared minus 5x. Now at this point is when we're going to do something called exponentiating, and what we're really doing is we're taking advantage of this property. Remember, if you have b raised to the log base b of x, the base b and the log base b cancel each other out, leaving you with just the x that was inside of the log. Well, it's the same thing we're going to try to do here. We're going to exponentiate, in other words, raise both sides of this equation into the exponent with the same base. And that base we're going to use is whatever the base of this log is, so that it cancels out. So in this case, we'll be exponentiating with a base of 6. So we'll have 6 raised to the log base 6 of x squared minus 5x, I'm sorry, I left off an x here, equals 6 squared, right? 6 raised to the second power. Now, at this point, remember, if we use this property over here, 6 to the log base 6, that cancels out, leaving us on the left side with just x squared minus 5x. On the right side, 6 squared is 36. So from here, we can just solve this relatively simple quadratic. X squared minus 5x minus 36 equals 0. This factors nicely to x minus 9 times x plus 4 equals 0. And then from there, we get x equals 9 or x equals negative 4. So we're done up through step 3 now. Step 4, remember, is to check our answer. In other words, we need to make sure that when I plug in 9, I don't have I'm not trying to do the log of a negative number. And when I plug in negative 4, I'm not trying to do the log of a negative number. Well, if we test 9, we get log base 6 of 9 minus 5 is 4, plus log base 6 of 9. Both of those, we're doing the log of a positive, so that's fine. When we test x equals negative 4, we get log base 6 of negative 4 minus 5 is negative 9, plus log base 6 of When we plug in -4 for x, we just get -4 here. So actually both of these are no good because we cannot do the log of a negative number. So that means that x equals -4 does not work. Our only actual answer is x equals 9. Second example. Again, step 1, we have to condense the logs. So we turn this into log base 2 of x over x minus 3. We have to use the quotient property this time, it's the subtraction in the middle, equals 3. Now we exponentiate with a base of 2 this time. So 2 to the log base 2 of x over x minus 3 equals 2 raised to the third. 2 and log base 2 cancel out, leaving us with x over x minus 3 equals 2 cubed is 8. And from here we just solve our equation normally. So we don't want this x in the denominator, so we're going to multiply both sides by x minus 3, giving us x equals 8 times x minus 3. Simplify a little bit, x equals 8x minus 24. From here we solve for x minus 8x over this side, negative 7x equals negative 24, and divide both sides by negative 7, x equals 24 over 7. Again, we should check to make sure that actually works. So when we go ahead and test it, we will get log base 2 of 24 over 7 minus log base 2 of 24 over 7 minus 3. Well, 24 over 7 minus 3 comes out to 3/7. And 3/7, even though it's a small number, is still positive. It's still greater than 0. We can do both of these logs. So this is actually a valid answer.